Alkenes are unsaturated hydrocarbons. They contain a double bond, so each carbon is not bonded to 4 other atoms. General formula is CnH2n. The general rules apply when we name, but the double bond takes precedence when naming. So for example, let's say we have this compound right here. It is an alkene because it has a double bond. The double bond takes precedence when numbering, so I have to start over here with carbon 1, and then 2, 3, 4. I have substituent groups on carbon 3. We're going to name these substituents first. So we're going to say 3, 3. Those are methyl groups. 3, 3 dimethyl. Longest chain is 4, but I have to indicate where the double bond starts. The double bond starts on carbon 1. So 1, and then this is butene. The suffix changes to ene because there is a double bond. With alkenes, we have cis-trans isomers possible because there is no free rotation around the double bond. So for example, this compound right here, since the chlorine are on the same side, this would be called cis. And then we're going to say 1, 2 dichloroethene. So this is cis 1, 2 dichloroethene. I don't have to indicate where the double bond starts because there's only 2 carbons, so obviously the double bond starts on carbon 1. There's also a molecule that looks like this, where the chlorine are on opposite sides. It's going to be named exactly the same, except it's going to be trans. 1, 2 dichloroethene. And again, this is because there's no free rotation around the double bond. Reactivity. Alkenes with double bonds are more reactive. And we'll look at some reactions with alkenes in the second part of organic. Alkynes. These are unsaturated. They contain a triple bond. General formula is CnH2n-2. Let's look at an alkyne. Just like with alkenes, the triple bond takes precedence. So we're going to start numbering over here. 1, 2. We're going to go up to the longest chain, which is 6. We have a substituent on carbon 5. So we're going to name the substituent first, which is a methyl group, so it's 5-methyl. Longest chain is 6, but we have to indicate where the triple bond starts. The triple bond starts on carbon 2. So 5-methyl 2 hexyne. 5-methyl 2 hexyne. Aromatic hydrocarbons. These contain a benzene ring, C6H6. Normally a benzene ring is written like this. It has a resonance structure. By moving those double bonds, I can get an identical structure that looks like this. So this is the benzene ring. Sometimes the benzene ring is written like this with a circle in the middle. Now the actual structure is planar and each carbon is sp2 hybridized. So either way you want to write the benzene ring is acceptable. Fused ring systems. These contain 2 or more rings that have 2 carbons in common. Naphthalene has 2 benzene rings. Anthracene is 3 fused benzene rings. And then pyrene has 4 fused benzene rings. When we name benzene rings, there are mono-substituted benzenes. We don't have to have a number to indicate the substituent. For example, This is a mono-substituted benzene. I would just call this chlorobenzene. I don't have to say 1-chlorobenzene because I know it's on carbon 1. There's only one substituent group. This compound would be called nitrobenzene. The NO2 group is called nitro, so nitrobenzene. If I have two or more substituents, I'm going to follow the rules that I've been using so far. So let's say we have this compound right here. I want the most groups on the lowest possible number, so I'm going to start numbering right here with carbon 1, carbon 2, carbon 3, carbon 4. Bromine comes first alphabetically, so they're listed first. So it'd be 1, 2, dibromo. Chlorine's on carbon 4, so 4, chloro, and then benzene. So we're going to follow the rules we followed before. We want the most groups on the lowest possible number, and then we list substituents alphabetically while ignoring the prefixes. So bromo comes before chloro. If you have di-substituted benzene derivatives, the Greek prefixes ortho, meta, and para are often used. Di-substituted means you have two substituent groups. This compound right here would be called ortho dichlorobenzene. So ortho means the 1 and 2 positions. You could also call this 1, 2 dash dichlorobenzene. If you have the 1 and 3 positions, like this compound right here, this is called meta dichlorobenzene. So the 1-3 positions. And then finally, you can have the 1-4 positions for a di-substituted, and that would be called para dichlorobenzene. But know what the prefixes mean: ortho, meta, and para. Heterocyclic compounds contain an atom that is not carbon, most commonly nitrogen, oxygen, sulfur. This is pyridine. And here are some biochemistry molecules that are of importance with organic chemistry: adenine, guanine, thymine, cytosine, and uracil. This is kind of for your own information. I'm not going to test you on these biochemistry molecules.